Hello guys, welcome to another video on the GC4 YouTube channel. I'm always yours for today, and in today's video we're going to be correcting the Cameroon GCE Advance Level 2020 Maths Mechanics Paper 2. Let's begin. Here we have our question paper which you can download from the GC4 website. And in our question paper, here we have our questions. The first question says, given that x plus 1 is a factor of f of x, where f of x equals x cubed plus 6x squared plus 11x plus 6, factorize f of x completely. So to respond to that, let's create a new file where we're going to store all our answers. So f of x is equal to this, that is x cubed plus 6x squared plus 11x plus 6, and to factorize this completely, we are given the factor of f of x as x plus 1. So to factor this completely, we are simply going to proceed by dividing f of x by its factor, which is x plus 1, using the long division method. Now I don't know how to do long division on a computer, so I'm just going to do a table to simulate like a long division type of thing. So a table like this, and in this table, say we merge this for the quotient, here is the dividend, and here is the divisor, which is x plus 1, and the dividend, which is f of x. Right, let's see. Right, first things, x cubed divided by x, that's x cubed divided by x is going to give us x squared. So that's x squared. X squared times x is equal to x cubed, and x squared times 1 is equal to x squared. Now we're going to do a subtraction. X cubed minus x cubed is equal to nothing. 6x squared minus x squared is equal to 5x squared. Now we continue the division. You bring down this 11x, and we continue with the division. 5x squared divided by x is equal to 5x plus 5x. 5x times x is equal to 5x squared, so 5x squared. And the 5x times 1 is equal to 5x. We do the subtraction again, and 5x minus 5x is equal to 0. 11x minus 5x is equal to 6x. We bring down this last digit, which is 6, and we continue with the last piece of the division. 6x divided by x is 6, and 6x times x is 6x. 6 times 1 is 6, and when we do the subtraction, it ends 0, 0. Normally, since x plus 1 is a factor of f of x. Now from here, we continue by considering our quotient, which is x squared plus 5x plus 6. What we have to do now is that we have to factorize this quotient, and to factorize this, we simply need to look for values of this constant 6, which when we multiply them together, we're going to get 6, and when we add them together, we're going to get 5. Factors of 6 include 1, 2, 3, and 6. And among these factors, you see that if you multiply 2 and 3, they're going to give us 6, and if you add 2 and 3, they're going to give us 5. So this quadratic equation turns to x squared plus 5, x squared plus 2x plus 3x plus 6. Now if you take this first pair of values, that's x squared and 2x, you factor out x in there, it's going to give x into x plus 2. And for the second set of value, you can factor out 3 to get 3 into x plus 2. That's x plus 2. Take note that we're trying to make what's in this bracket the same. And from here, we now bring these two terms together. That's the x and the positive 3. So that's going to give x plus 3 into x plus 2. Now we have factored the quadratic equation. And to end the question says factorize f of x completely, which is this polynomial of degree 3. To factorize this polynomial completely, you simply need to multiply this factorized quadratic equation by is the first factor of f of x, which you use to divide f of x to get the quadratic equation. So if you put this times x plus 1, you have factorized f of x completely, and that is the answer of the first question. That is the answer of question 1.11. Now moving down to question 1.12, which says let lambda be a real constant. Show that the roots of the quadratic equation 3x squared plus bracket open minus 4 into minus 2 lambda plus x plus 2 lambda equal to 0 are always real. Now The main thing in this question is that we have to prove that the roots of that quadratic equation are always real. And for the roots of a quadratic equation to always be real, the discriminant of that quadratic equation, which is x squared and b squared minus 4ac minus 4ac, should always be greater than or equal to 0. We have our quadratic equation, which is this, working on 18. Alright, so that's 3x squared. This is always greater than or equal to 0. So our b here is minus 4 minus 2 lambda. So this squared minus 4 into our a here is 3 and our c here is 2 lambda, so that's 3 times 2 lambda should always be greater than or equal to 0. From here we open the brackets here, so that's going to be this minus 4 times 3 times 2 lambda is equals to 6 lambda times 4 is equals to minus 24. Yeah, times 4 is equal to 24, so that's minus 24 lambda. This should be always greater than or equal to 0. Now if you open the brackets here, negative 4 times negative 4 is equal to 16. Negative 4 times negative 2 lambda is equals to plus 8 lambda. Negative 2 lambda times negative 4 lambda is equals to plus 8 lambda again. And finally, negative 2 lambda times negative 2 lambda is equals to plus positive 4 lambda squared. And this should always be greater than or equal to 0. Now from here we can decide to factor out 4. So we put 4 out there and into the equation. This becomes 4 plus 8 plus 8. Oh yeah, of course, I forgot minus 24 here. Minus 24 lambda, let's not forget. Yeah. So 8 lambda plus 8 lambda is gives us 16 lambda. 16 lambda minus 24 lambda gives us negative 8 lambda. So that's going to give us minus 2 lambda. And finally, 4 lambda squared is just turns to lambda squared. So that's what factoring out 4 gives us, plus lambda squared. And this should always be greater than or equal to 0. So from here we can proceed by factoring out what's in this bracket, and we can do that by completing the square. To complete the square of a quadratic equation, we simply need to, the first step is by adding and subtracting the square of half of the coefficient of the x term, or in our case we're going to add and subtract the square of half of the coefficient of the lambda term, and the coefficient of the lambda term here is negative 2. Negative 2, half of negative 2 is equals to negative 1. So completing the square, we begin by putting 4 into, rearrange this like normal quadratic equation, so that gives us lambda squared minus 2 lambda plus 4. Now to complete the square of this is going to be equal to 4 into, we're going to add and subtract the square of half of the x term. Half of 2 is equals, half of negative 2 is equals negative 1. So that's going to be lambda squared. And of course x term will no longer exist, so lambda squared plus negative 1 squared minus negative 1, that's negative 1 squared again, and finally plus 4. Now the next step for completing the square involves grouping the value which you're adding, that's the square of half of the x term which you're adding with the x squared value or with the lambda squared value, putting them in one bracket and sending the square sign out. So this turns to 4 into, brackets open, lambda minus 1 squared, and here we have minus 1 squared is 1, minus 1 plus 4 is equals to plus 3, and that should be it for the equation. This should always be greater than or equal to 0. Now looking at this equation, you see that no matter the value of lambda here, this always tends to be positive. Even if lambda is negative, lambda is positive, lambda is 0, this value always ends up being negative because of this square sign. And plus 3 is still a plus times 4 is still a plus. So no matter the value of lambda in this equation, the equation is constantly increasing. So this equation is always greater than or equal to 0 for that's for all values of lambda. Hence the root of the equation, the roots of the equation are always green. So that's basically it for question 1. So now we proceed to the next question, which says solve the differential equation dy dx equals to x y minus x, given that y is equal to 2 and x equals to 0, expressing y in terms of x. Right, this is the differential equation. Dy dx is equal to xy minus x. Right. So to solve the differential equation, the first thing we need to do is to group the like terms together. That is, we're grouping the x terms and the y terms. And to do this, you can start by factoring out x in this. That's going to be equal to x into y minus 1. Alright, we are now on question 2, and question 2 Roman 1 says, given that y is equals to ln 4x plus x squared, find dy dx. So the differentiation of a line function is simply the differentiation of what's in the line function all over what's in the line function. So in this case, the differentiation of ln 4 plus x squared is simply going to be the differentiation of 4 plus x squared all over 4 plus x squared. So if you have to do this here, let's just write. So that's simply going to be dy dx of ln 4 plus x squared, that's 4 plus x squared, is going to be the differentiation of 4 plus x squared is simply equal to 2x, because the differentiation of the constant is 0. So that's 2x all over 4 plus x squared. So that's going to be 2x on 4 plus x squared plus x squared, and that's the differentiation of y. Alright, so moving on, the question says the equation of the tangent and the normal to the curve y is equals to ln 4 plus x squared at the point where x is equal to 1. Alright, you have given the condition at the point where x is equal to 1. So to do that, you simply start by substituting x equal to 1 into this equation, that's ln 4 plus x squared, to get the value of y. So y is equal to ln 4 plus x squared. So when x is equal to 1, then substituting 1 here is simply going to be ln 4 plus 1 is equal to ln 5. So y is equal to ln 5. Now the point is simply x is 1 and y is ln 5. Now 2 Roman 2 says the equation of the tangent and the normal to the curve y is equal to ln 4 plus x squared at the point where x is equal to 1. So to solve this, you simply need to know the equation of the line. Let's say equation of a line. The equation of the line is generally given by y minus y0 is equal to m into x minus x0. Now in the case of finding the equation of the line of the tangent, let's call the gradient of the tangent, say mt. The gradient of the tangent, we simply have to differentiate the function y, or the equation of y, and substitute the values of x in it. Here I've already done the differentiation of y, which gave us 2x on 4 plus x squared. So simply substitute the value of x, which is x equal to 1, in this equation to find the value of the gradient of the tangent. 2 times x, that's 2 times 1, all over 4 plus x squared, that's 4 plus 1 squared. That is going to give us 2 on 5. on 5, and this is the gradient of the tangent. Now we simply substitute these and other respective values in the equation to find the equation of the tangent. So we can just do this, and y0 is equal to ln 5. y0 is equal to ln 5. The gradient is equal to 2 on 5, and the x0 is equal to 1. So this is the equation of the tangent. And now we proceed to find the equation of the normal. To find the equation of the normal, you just simply have to understand the relationship between the tangent and the normal, which is the gradient. And the relationship is that the gradient of the tangent, say mt, the gradient of the tangent, say mt, times the gradient of the normal, say mn, is equal to -1. This is the relationship between the gradient of the tangent and the gradient of the normal, but the equation of the line still remains the same, so we simply need to find the gradient of the normal and substitute it in this equation to get the equation of the tangent. So from this you understand that the gradient of the normal, which is mn, is simply equal to -1 on the gradient of the tangent, mt. So that's -1 on 2 on 5 is going to give us -5 on 2. That's -5 on 2. And this is the gradient of our normal. We just substitute it in this equation. Control V. And now m is equal to -5 on 2. x0 is equal to 1. And y0 is equal to 5. We can send a negative sign inside to make it. And y is equal to 5. And this is the equation of the normal. So that's basically it for question 2 Roman 2. We can move to the next 2 Roman 3. Solve the differential equation dy dx is equal to x y minus x, given that y is equal to 2 and x is equal to 0, expressing y in terms of x. Right, this is the differential equation. The equation says dy dx is equal to xy minus x. Right? So to solve the differential equation, the first thing we need to do is to group the like terms together. That is, we are grouping the x terms and the y terms. And to do this, you can start by factoring out x in this. That's going to equal to x into y minus 1. And now we divide both sides. We divide both sides by y minus 1 and multiply both sides by dy dx to group x and dx together and dy and y minus 1 together. That's going to give us, so integration of this is simply, we're integrating dy on y minus 1, okay, is equal to x dx. Now from here we can simply proceed by integrating this. So integrating y d1 dx and equal to the integration of x dx. Now integrating 1 dx, that's the integration of 1 on y on 1. Notice that if we differentiate y minus 1, we're going to get 1, which is the same as the numerator. So for the laws of integration, if you can differentiate the denominator to get the numerator, then the integration of that function is simply going to be equal to ln y minus 1. That's ln the denominator, ln y minus 1, is equal to the integration of x is simply equal to x squared. So x squared plus the constant k, or c, any constant. Now from here we get some values which say, given that y is equal to 2 and x is equal to 0, we have to substitute these values in this equation to get the value of the constant k. So when y is equal to 2, ln 2 minus 1 is equal to 1, so that's ln 1 is equal to x is equal to 0, so 0 plus k. Ln 1 is equal to 0, implying that k is equal to 0. And then we now substitute the value of k into this equation. This is going to give us ln y minus 1 is equal to x squared. That's then y minus 1 is equal to x squared. And from here we can proceed to expressing this equation in terms of x and y. To do this, we simply have to eliminate this ln sign from here, and to eliminate this, we simply raise everything to e. This is going to turn to e raised to ln y minus 1 is equal to e raised to the ln x, so that's e raised to x squared, e raised to x squared. And now e raised to ln of any value is simply equal to that value, so that's going to be y minus 1 is equal to e to the x squared. And that's the answer of question 2 Roman 2, question 2 Roman 3 rather. And that brings us to the end of question 2. Now moving on to question 3, they say draw the truth table for each of the propositions P implies Q and the negation of P or Q and show that they are identical. So we draw our truth table, which is P, Q, negation of P, P implies Q and negation of P or Q, and there are 4 possible values. Right. So okay, let's do this. And here's our table. I don't think it's enough. Alright, now the values of P we have true, true, false, false. Values of Q we have true, false, true, false. The values of the negation of P we have false, false, true, true. That's P is true, so negation of P is false, P is false, negation of P is true. Now moving on, we have P implies Q. When you say P implies Q, simply the conditions for this should be true. Either Q is true or P and Q are the same. So looking at here, we have Q being true, so the value is true. Here Q is false, so no matter the other, here Q is false and P is true, they are not the same, and Q is false, so the value is false. Here Q is true, so the answer is obviously true. And finally here Q is false but P is also false, the values are the same, so it's true. Now we move on to the next one, negation of P or Q. Here, if any value is true, then the result is true. The negation of P and Q, it is a true value, so this is true. Here, all of them are false, so this is false. Here, all of them are true, so this is true. Here, negative Q is true, so this is true. Now, if you look at this, you see that P implies Q and the negation of P or Q, each entries, their respective entries are the same, true, true, false, false, true, 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 true. From here, we can conclude that P implies Q, that's P implies Q, is logically equal to the negation of P or Q as required. So that's it for question 3 Roman 1. And now I move to question 3 Roman 2, which says given that sin inverse x equals to alpha and cos inverse x equals to beta, show that sin alpha plus beta is always equal to 1. Now to understand this, you simply need to understand the relationship between sine and cos. And if you look at the graph of y is equals to sine theta and the graph of y is equals to cos theta, you always notice that for a specific value, sine theta is always ahead of cos theta by 90 degrees. So no matter the value, if sine theta, no matter the value, sine inverse theta plus cos inverse theta will always give you 90 degrees. So that gives us this identity, this trigonometric identity. We say sine inverse, in our case, let's say sine inverse x plus cos inverse x is always and will always be equal to 90 degrees or pi on 2. Let's use 90 degrees. Always be equal to 90 degrees or pi on 2. Now from the question, sine inverse x is equal to alpha plus cos inverse x, which is beta, is always equal to 90 degrees. Now we take the sine of both sides, so that's sine alpha plus beta, sine alpha beta, that's sine alpha plus beta is equal to sine 90, and sine 90 is equal to 1. So this sine alpha plus beta is equal to 1 as required. That's it for question 3.2, and that's it for question 3 as well. Now moving to the next question, question 4. It says the function f of x is given by f of x equals x squared all over x minus 1 is x squared plus 1. Express f of x in partial fractions. To do this, f of x is equal to x plus 1. That's f of x is equal to x plus 1 all over x minus 1 into x squared plus 1. So f of x equal to x minus 1 into x squared plus 1. And this is logically equal to, we partial fact this is going to give us, since the first that's the numerator, the first, what's in the first bracket is a linear equation, that's going to give us a all over x minus 1 plus, what's in the second bracket is a quadratic equation, so that is going to give us bx plus c all over x squared plus 1. That's x squared plus 1. So now we proceed by dividing each fraction, that's each fraction, by the numerator of f of x, by the denominator of f of x, which is x squared, x minus 1 is x squared plus 1, and this is going to give us a into x squared plus 1, a into x squared plus 1 plus bx plus c into x squared plus, into x minus 1 rather, x minus 1, and this is equal to x plus 1. Okay, now we start by eliminating terms in order to find the values of a, b, and c. And we start by saying let x equal to 1. Substituting 1 in this is going to give us 0. Bx plus c times 0 is 0, so I'm going to be left with a. 1 squared is 1, 1 plus 1 is 2, so 2a is equal to 1 plus 1 is 2 is 2, implying that a is equal to 1. That's our first value, a. Now you find the second value. You can eliminate b by letting x equal to 0. When x is 0, is going to give us, the equation is going to give us a minus c is equal to 0 plus 1 is 1. So what's a? A is equal to 1. 1 minus c is equal to 1. You send 1 the other way, it becomes 1 minus 1, 0. So c is equal to 0. That's our value of c. And finally, from here we can proceed to finding the value of b. Let's just say without eliminate c again. So you cannot eliminate c without eliminating b as well. So you can just say let x be equal to 2, for example. Now this equation turns to 2 squared is 4, 4 plus 1 is 5. That's going to give us 5a plus 2 here, 2 minus 1 is 1, 2 times b is 2, that's 5 plus 2b plus c is equal to 2 plus 1 is 3. Now a is 1, so 5a is equal to 5, b is the unknown, so 2b, and finally c is equal to 0. So you can just open that, is equal to 3. If you send 5 the other way, this equation turns into 2b is equal to 5 minus 3 is negative 2, implying that b is equal to negative 1. So now that we have all the values of a, b, and c, we can proceed by substituting these values in this equation to get the partial factored equation. So you can just copy this and paste it here. The value of a is 1, the value of b is negative 1, so you can just put that here, minus x, and the value of c is 0, so you can omit that, and this is the partial factored equation. So to conclude, we should put this as our answer. This is the answer of the partial factored equation. Now the next question says, hence find the integral of f of x dx. The integral of f of x dx is simply the integral of this. So that's the integral of this, right, minus the integral of this. Okay, the integral of this, as we did earlier for y minus 1, is simply equals to ln x minus 1. So that's ln absolute value. It's absolute value because there's never a ln of a negative number, so ln x minus 1, and minus the integral of this is simply 1 on 2 times x squared plus 1, so that's just x squared plus 1 on 2, or let's just say 1 on 2 into x squared plus 1. So this is the integral of f of x dx, so we can just write the integral of f of x simply equal to this, and here's your answer. Now the next question 4.2 says, by using the substitution is equals to sin x, find the integral of cos x on 1 plus sin x dx. Okay, so by using the substitution, u is equal to sin x, and du on dx, du on dx is simply equal to cos x. That is differentiation of sin x is equal to cos x. And then we continue. So du on dx is equal to cos x. Now we substitute these values in this equation. That's cos x over 1 plus sin square x. So cos x is equals to du on dx, and dx is going to cancel, the dx here is going to cancel this dx. So that's going to leave us with du, or let's put that function. That's going to leave us with du all over 1 plus sin square x is 1 plus u squared, 1 plus u squared. So that's going to be what this is what we're going to integrate now. So it's the integral of this, which by definition, like the law of integration says, the integral of 1 on 1 plus x squared is simply equal to tan inverse x. So this is going to be equal to tan inverse u, simply tan inverse u, and we know that u is equal to sin x, so this will be equal to tan inverse sin x, and let's put that in a bracket, and this is the answer of the question. Finally, you can move down to 4 Roman 3, which is find the integral of x plus 2 e to the 3x dx. Alright, we're going to integrate x plus 2 into the integral x plus 2 into e to the x plus 2 e into the 3x e to the 3x dx. This is what we are integrating, and now this is the product. We're going to use the product rule of integration, where it says the integral of uv, the product rule says the integral of u dv is simply equal to uv minus, uv minus the integral of v du. So this is the product rule of integration. We're going to find our u, which is x plus 2. So u is equal to x plus 2, and du, we differentiate x plus 2 to get 1. Then v, that's the v rather, is equal to v is equal to, that's e to the 3x. So v is simply the integration of e to the 3x. V is equal to integration of e to the 3x. The integration of e to the 3x is simply 1 on 3 times e to the 3x. That's 1 on this, 1 on the differentiation of this all over times e to the 3x. So v is equal to 1 on 3 times e to the 3x. E to 3x is basically the same thing. So this is u, this is v, this is v. So now simply substitute this into this equation and we're done, good to go. So u is equal to x plus 2. X plus 2. V is equal to e to the 3x on 3. So we'll just copy this. And minus the integral of v du. This is v, that's the integral of this, and du is 1, so that's simply the integral of this, and this can be written as 1/3 the integral of this. So you can just put this out, 1/3 the integral of e to the x. Oh my god, 1/3 the integral of e to the 3x. And this integrating e to the 3x as it did before is simply 1/3 e to the 3x. So this equation will boil down so that minus 1/3 e to the 3x times 1/3 e to the 3x again, or just say times 1/3 e to the 3x. So 1/3 e to the 3x times 1/3 e to the 3x, simply 1 on 9 e to the 3x. So let's make life easy for everybody and put it here, 1 on 9 e to the 3x, and that is the interval of like the equation. We can decide to sum this up, like do the mathematical computation. That's going to give us, so this is equal to 9 divided by 3 is 3. 3 times that is equal to 3 into x plus 2. 3 into x plus 2 times e to the 3x. Control C, Control V. Into x plus 2 times e to the 3x minus e to the 3x. That's e minus e to the 3x, all these on 9. So we can just Control X, insert the function, Control V, all this on 9. And that's your answer for the question of question 4, command 3, and that's basically it for question 4 as a whole. The next question, question 5, says given that circle 1, which is equal to x squared plus y squared minus 6x minus 4y plus 9 equal to 0, and circle 2, x squared plus y squared minus 2x minus 6y plus 9 equals 0. Find the equation of circle 3 which passes through the center of circle 1 and through the point of intersection of circle 1 and circle 2. Alright, now to solve this, first we need to know the equation of a circle. The equation of a circle is in the form x squared plus y squared plus 2gx plus 2gy plus 2fy plus c is equal to 0. Now from this equation we should know that the values of the center of the circle is equal to negative g and negative f, negative g negative f, and the radius of the circle radius is equal to, and the radius is equal to the square root of g squared plus the square root of f squared, so let's just write this, minus c, so g squared f squared. This is the formula for the radius of a circle. Now we can proceed to find the radius and the center and the radius of circle 1 and circle 2. Now for circle 1, we have that, this is the equation of circle 1, this and this, and negate that we have that 2g is equals to negative 6, so 2g is equal to negative 6. As from the general equation of a circle, 2g is equal to this, so negative 2g is equal to negative 6, implying that g is equal to negative 3, and 2f is equal to negative 4, implying that f is equal to negative 2. Now the coordinates of the center is simply equal to negative g, negative f. So that's going to be negative 3 is 3, negative 2 is 2. These are the coordinates of the center of circle 1, C1. Now we proceed by finding the same for circle. Now we proceed by finding the radius of circle 1. The radius. Now we proceed by finding the radius of circle 1. The radius of circle 1 is simply the square root of this. So g squared is equal to 3 squared, 3 squared is equal to 9. F squared is equal to 2 squared, 2 squared is equal to 4. And c is, from the equation, c is 9. And c is, from the equation, we have that c is equal to 9. So 9 minus 9 is 0, the square root of 4 is equal to 2. That's the radius of circle 1 of C1. Now we proceed by doing same for the circle 2. So we can just copy this. So we can just copy this for circle 2. Now for circle 2, we have the equation of the circle is x squared plus y squared minus 2x minus 6y plus 9. So that's x squared plus y squared minus 2x minus 6x plus 9. Right. So that's the equation of circle 2. We have that 2g is equal to negative 2, and g is equal to negative 1, and minus 2f is equal to minus 6, and f is equal to minus 3. The coordinates of the center are 1, 3. Now the radius is simply going to be 1 squared is equal to 1, 3 squared is equal to 9, and c is equal to 9. This is equal to the square root of 1, which is equal to 1. That's R of C2, and this is of C2 and C2. So this is basically it for the center and radius of circle 1 and circle 2. We now proceed to finding the point of intersection of circle 1 and circle 2. Now the point of intersection of circle 1 and circle 1 will be equal to circle 2. So with that in mind, we simply equate the equations of circle 1 and circle 2. This is circle 1, contrary, and this is circle 2. This should be equal. So circle 1 is equal to circle 2. Now we can bring items together, add and subtract when necessary. This is going to be equal to x squared plus y squared minus x squared plus y squared is equal to nothing. Negative 6x plus 2x is equal to negative 4x, negative 4x. Negative 4y plus 6y is equal to 2y plus 2y. And finally, 9 minus 9 is equal to 0. This is equal to 0. So this can be written as y, or this can be written as 2y is equal to negative 4x. 2y is equal to 4x. Hence y is equal to 2x. This can be written in this form. Now this is like the equation of the line passing through the points of intersection of circle 1 and circle 2. Now we can proceed to solving the next part of the equation. Now simply substitute y is equal to 2x into any of the equation, that's either equation 1 or equation 2. You can decide to use equation 2 since it looks like it's complicated. So using equation 2, that's, so you can say substituting y equals 2x in equation of circle 2, we have y is equal to 2x, so this is equal to 2x squared. 2x squared is equal to 4x squared. Then 6y is equal to 6 times 2y, that's 12y squared, 12x. And this is what you have. Now summing up all the values, all the like terms, you have x squared plus 4x squared, you have 5x squared, minus 2x minus 12x equals to minus 14x, and finally plus 9 is equal to 0. Alright, now we can use the quadratic formula to find the possible values of x from this equation. Now the quadratic formula is b squared minus 4ac. Here's the quadratic formula. Now just to substitute the values in here, which is equal to, what is negative b? Negative b is negative 14, which is 14. 14 positive minus b squared is 14 squared, so minus 14 squared minus 4 into ac. So that's 14 squared minus 4 into ac. AC is 5 times 9, which is 45. That's 4 times 45. 4 times 45 is 180, so you can just write that to not waste time, 180. Now 2a is 2 into 2 times 5, which is 10. So this means x is equal to a fraction of 14 plus the square root of 196 minus 180. The square of 14 is 196. 196 minus 180 is 16. That's 14 plus the square root of 16 is 4. So let's just write that here, 14 plus 4 on 10, or x is equal to basically the same thing but with a minus sign. That's 14. Oh no, this 14 minus 4 on 10. Now 14 plus 4 on 10 is equal to 18 on 10, is equal to, implying that x is equal to 18 on 10 on 10, or x is equal to 14 as 10 on 10, which is 1. Now these are the two values of 10. This can be written as well as 9 on 5, which is equal to 9 on 5. So x is equal to 9 on 5, or x is equal to 1. Those are the two possible values of x. Now I'm going to find the value of y using these values of x. So we know y is equal to 2x when x is equal to 9 on 5. So y is equal to 2x when x is equal to 9 on 5. Control V. y is equal to 2 into 9 on 5, that's equal to 18 on 5. Y is equal to 18 on 5. So that's the first point of intersection, which is x is 9 on 5 and y is 18 on 5. Alright, now from here we're told that circle 3 passes through the center of circle 1 and through the 2 points of intersection of circle 1 and 2, which are these. And now from the question we're told that circle 3 passes through the center of circle 1 and through the 2 points of intersection of circle 1 and circle 2. So we're going to substitute those values of that's the center of circle 1 and the 2 points of intersection of circle 1 and 2 into the general equation of the formula, and this is going to give us a system of equation with 3 unknowns, which are going to be f, g, and c, and we're going to solve for these 3 unknowns to get values which you can substitute to get the equation of circle 3. What I mean by that is the center of circle 1, as we calculated here, was 3, 2, that's x equal to 3 and x equal to 2. Now this is the general equation of a circle, and using 3, 2, substituting it in this equation, you get x equal to 3, right? So was 3 squared, y is equal to 2 squared, gx equal to 3, fy is equal to that. So now doing our computation, we get 3 squared is equal to 9, 9 plus 2 squared is equal to 4, so 9 plus 4 is 13, plus 3 times 3 is 6g, and 2 times 2 is 4f. 2 times 3 is 4f plus c is equal to 0. Now we send like the constant there. To send the constant to the right hand side, that's going to be 6g plus 4f plus c is equal to minus 13. You can call that equation 1. Now we're going to substitute the next value, which are the values of which are the points of intersection, and you have, so here you had just the first point of intersection. So the second point of intersection is when x is equal to 1, y is equal to 2. So the second point of intersection is 1, 2. And now substituting those points into the equation of the line, we get using 1, 2, we get x is equal to 1, so 1, y is equal to 2 times 1 times 2 is equal to 0. 1 plus 4 is equal to 5 times 2, that's going to give us 2g plus 4f plus c is equal to negative 5. You can call that equation 2. And now moving on, we use the last set of values, which are 9 on 5 and 18 on 5, v into the general equation of the circle, which is this. So when we do this, x is equal to 9 on 5, so you have 9 on 5 squared, and y is equal to 18 on 5, so you have 18 on 5 squared. Just take note that this is squared. And you have 2 into x, which is 9 on 5, and you have 2 into y, which is 18 on 5. Moving on, if we do the simplification, 9 on 5 squared is equal to 81 on 25. So that's 81 on 25. 25 plus 18 squared on 5 is equal to 324 on 5. That's going to give us 324 on 25 rather. Then 2 into that is going to give us 18 on 5G plus 18 plus 18 on 5G plus 2F is equal to 18 times 2, that's 36 on 5F, so 36 on 5F, that's 36F on 5, yeah, plus C is equal to 0. Now from here we add these two values, 81 plus 324, that should give us 405, so that's 405 on 25, so that's 405 on 25 plus 18G plus yada yada yada. If you simplify this, like 25 divided by 405, 5 here goes 5 times, 5 here goes 81 times, so that will give us, that will turn this into 81 on 5. Now we can multiply all the terms by 5 to get this, like to remove the fraction. So we're going to get 81 times 81 on 5 times 5 is 81 plus 18G plus 36F plus 5C is equal to 0. Now we send 81 the other way, that is going to give us minus 81, and remove this 81 from here, and you can call this equation 3. So that's it for all the 3 equations you need. Now we can, looking at the equations, you have equation 2, equation 1. You see that equation 1, the value of the coefficient of C is 1. So if you subtract equation 1 from equation 2, be able to eliminate C. Subtracting equation 1 from equation 2. So let's say EQN1 minus EQN2 is equal to, we have that 6G minus 2G is equal to 4G. 4F minus 4F is equal to 0. C minus C is equal to 0. Minus 13 minus 5 is equal to minus 13 plus 5, which is equal to minus 8. So 4G is equal to minus 8, implying that G is equal to minus 2. This is the first value of G. This is the value of G we've gotten. Now we proceed to finding the other values. We can decide to substitute the value of G in equation 2 and equation 1 and equation 2. So from here we substitute the value of G into equation 3 to get another equation. So substituting G equals negative 2 here is going to give us negative 36 plus 36F plus 5C is equal to minus 81. Now we send 36 the other way, that's going to give us 36F plus 5C is equal to minus 81 plus 36 is equal to 45. Minus 81 plus 36 equals to minus 45. So that's, you can call this equation 4. And now we substitute as well the value of G in either equation 1 or equation 2. So substituting G is equals to negative 2, let's say we take equation 2. Negative 2 times 2 is equals to negative 4. Negative 4. 4F, negative 4 plus 4F plus C is equal to negative 5. So if you send 4 this way, it's going to give us negative 1. So 4F plus C is equal to negative 1. Now we can call this equation 5. Now solving equation 4 and equation 5 simultaneously, we'll get, solving equation 4 and equation 5 simultaneously, we get, let's say we multiply both, you multiply equation 5 by 2 and you subtract both. Let me just do it normally. Control C, Control V, Control C, Control V. You can decide to multiply equation 5 by 5. That's going to give us 20f plus 5c. That's why I'm multiplying this, so I want to eliminate c as equal to minus 5. Then we subtract both equations. 36 minus 20 is equal to 16f. 5 minus 5 is equal to 0. Minus 45 minus minus 5 is equal to minus 40, equals to minus 40. And now the value of f is simply f is equal to minus 40 divided by 16. That's going to give us 10 on 4, which is equal to minus 10 on 4. That's the value of f. And this is going to give us minus 10 on 4, or we can further simplify it as minus 5 on 2. Minus 5 on 2. This is the value of f. So f is equal to this. Now we substitute the value of f into equation, that is equation 5. So we have 4 into 5 on 2, so that's 4 into minus 5 on 2 plus c is equal to minus 1. So 4 into minus 5 and 2 is equal to minus 10. Minus 10 plus c is equal to minus 1. So c is equal to 9. C is equal to 9. And this is what we have as the value of c. Now with that finally done, we're going to substitute all these values into the equation of that's the standard equation of a circle, and we're going to get the equation of circle 3. The equation of a circle is this. So Control C and Control V. The value of f we got, the value of x we got was right. So the value we got for g was g is equal to -2 and f is equal to -5 on 2. Substituting here, g is equal to -2, so that's going to give us -4. And f is equal to -5 on 2 times 2 is equal to -5y, so minus 5y, and c is equal to 9. So this should give us the equation of circle 3. The equation of circle 3 is equal to this. Gosh. This is the equation of circle 3 as required by the question. So that's it for question 5. Moving on to the next question, question 6. Alright, the next question is question 6, which says determine whether the function f of x equals to x plus 1 over x minus 3 with the domain x is not equal to 3 is surjective. For a function to be surjective, the domain of the function has to be equal to the codomain of that function. And the codomain of a function is simply equal to the domain of the inverse of the function. Now to find the inverse of this function, x plus 1 over x minus 3, I'm going to let y, or anything, let y be equal to f of x, right? Which implies y is equal to f of x is x minus 1, that's x plus 1 all over x minus 3, right? So let y be equal to this. Okay, no, come here, bro. Right, let y be equal to this. Now we're going to do a cross multiplication. That's going to give us yx minus 3y is equal to x plus 1. X plus 1. Then we're going to group the x terms together, so that's going to be yx minus x is equal to 1 plus 3y. We're going to factor out x here and divide it. We're going to factor out x. We want to make x the subject, so it's going to be x into y minus 1 is equal to 1 plus 3y. Then dividing both sides by y minus 1, you get that's x is equal to 1 plus 3y on y minus 1. Now we change the y to x, so the inverse, that's f of x inverse, f of x inverse, you can just say f of x prime is equal to, just copy this, and 1 plus 3, that's 1 plus 3x on y minus x. Now, to determine if this function is surjective, the domain of this function has to be equal to the domain of the initial f of x. The domain of f of x is not equal to 3. That's x an element of real numbers. X is not equal to 3. And you see the domain here, we have to put, if you equate the denominator to 0, x minus 1 is equal to 0, x equal to 1. So for this function to exist, x does not be equal to 1. So the domain of this function is x. X should not equal to 1. Hence we find that the domain of f of x is not equal to the codomain of f of x. Hence f of x is not surjective. So f of x is not surjective, and that's basically it to determine the function is surjective or not. Now, going down to the second question, Roman 2, they say a periodic function f max real number of period 4 is defined on the interval -2 is less than equal to x less than equal to 2 by f of x is equal to x squared plus 4x comma x between 0 and 2, and f of x is equal to negative x squared plus k f between x between -2 and 0. Find the value of k for which f is continuous and the value of f of minus 5. Alright, so for a function to be continuous, the left hand limit must be equal to the right hand limit. And if you look at this function, you see that the common values, that the common interval between the upper function and the lower function is 0, because there's a 0 here and there's a 0 here. So we have to write that, you have to check if the left hand limit as x tends to 0 is equal to the right hand limit as x tends to 0. Now, to do that, we simply substitute 0 in all these equations. Since they're linear equations, can just basically substitute 0 here, and you find that substituting 0 here is going to give us 4, and substituting 0 here is going to give us k, and since these two are the same, so 4 is equal to k, that's k is equal to 4, so just say k is equal to 4, and that's the value of k. Now they say find the function, find f of minus 5, right? F of minus 5, you have to know that this is a periodic function, and minus 5 can be the same, minus 5 is the same as 2 into minus 2 minus 1. So we're going to, so minus 5 is the same as f of minus 5 can be the same as f of 2 into minus 2 minus 1. With this, we're going to find f of minus 1. So we're just going to decompose minus 5 in such a way that we can get a value which exists in the range of f of f. Take note that negative 5 is out of the range of f of x, since the minimum value of f of x is -2 and the maximum value of f of x is 2. So we're trying to decompose this negative 5 in such a way that I can get a value which is in the range of f of x as defined by this function, and negative 1 is effectively in the range. So now we're going to substitute negative 1 in a function of f of x which negative 1 is in this range. And as you can see here, the first function is between 0 and 2, negative 1 is out of the range, and the second function is between -2 and 0, negative 1 is effectively in this range. So we're going to substitute f, we're going to find f of -1 of this function. So that's going to be f of -5 is equal to f of -1 of x squared, so of x squared plus k is 4, what we got here. And f of negative 1 squared is 1 plus 4. So f of negative 5 is equal to 1 plus 4 is 5, which is equal to 5, implying that f of negative 5 is equal to 5. And that's the answer for 6 Roman 2, 6a. Now going to 6b, they say sketch the graph y is equal to f of x for negative 2 less than equal to x less than equal to 10. So basically what we're going to do here is like we're going to find we're going to put like 3 values, knowing that it's a curve, right? We're going to take the first function, which is x squared plus 4, taking the first function, which is taking the first function, which is x squared plus 4. We can draw a table of values. You don't need much, just 3 values. So x, then f of x. We can use values. Say this f of x is between the range 0 and 2. So we can use the values 0, 1, and 2. Then when x is equal to 0, f of x is equal to 4. When x is equal to 1, f of x is equal to 5. When x is equal to 2, f of x is equal to 8. Right? We're going to do same for the second function, which is negative x squared plus k. So we draw a table for, just do this, Ctrl C, Ctrl V, negative x squared plus k, k is 4, so it's basically the same thing. And we draw a table of values. A table of values. We have x and we have f of x, and the values of the range of the second function is between negative 2 and 0. So you have negative 2, negative 1, and you have 0, 0. Now when x is equal to negative 2 squared is 4. That's negative of that squared, so that's going to give us negative 4. That's going to be 0. Negative 1 squared is 1. The negative of 1 plus 4 is equal to 3. And finally 0 squared 0 plus 4 is going to be 4. Now I'm going to sketch this curve, and knowing that range is 4, I'm going to repeat it till we get the range. And when you sketch it, basically your curve should look something like this. You see that the first value. Alright, so from here you're going to sketch the curve using these values, and your curve should look something like this. If I do it like this, you see that the first function, that's the first f of x, where f of x equals x squared plus 4, with values beginning from 0 to 1. These are the values here marked by the crosses. They continue from where this function f of x, where f of x equals negative x squared plus 4 stop, and they are marked by points. So the first point, the second point, the third point, and f of x continues from there to create this graph. Now since the graph has a period of 4, you are going to repeat the points after every 4 digits. So take for example, the first point starts at negative 2. Negative 2 plus 4 is equal to 2. That's why you have to repeat the point here. Here is negative 1 plus 4 is 3, and so on. And we're going to repeat this till it reaches the 10. Till it reaches 10, since the interval given in the equation was negative 2 to 10. So typically a graph should look something like this. And that should be it for this question. So from here, moving to the next question, which is question 7. It says find the image of the line so y is equal to x under the transformation in matrix operator 0, negative 1, negative 1, 0. So I have to transform the line. Let's put this. I have to transform the line y is equal to 2x using the matrix this 0, negative 1, negative 1, 0. So if you to transform this matrix, let's put this line in the parametric form. Say let y equal to t, then x is equal to 2t. Then this becomes, putting it in the matrix form, we get this. X is equal to 2t, y is equal to t. Now if you multiply this transformation matrix by this matrix, it gives us the transform x and the transform y. So this times this is equal to x, let's say the transform x, let's call it x bar, x prime, and the transform y, let's call it y prime. So let's do the multiplication. 0 times 2t is equal to 0, negative 1 times t is equal to negative t. So this should give us negative t, and negative 1 times 2t is equal to negative 2t, and 0 times 0 is equal to 0. So this should be equal to x prime y prime so this is equal to y prime. So x prime is equal to t and y prime is equal to 2t. So y is equal to x, so 2y. So the transform line is equal to y is the line of y is equal to x. So the transform line should be equal to 2y, 2t is equal to t. That's negative 2t is equal to t. But this t represents y bar, so now give us negative 2y prime is equal to negative y prime, negative x prime, sorry. So this means that the transform line is going to be 2y is equal to x, and this is the transform line under the matrix this. So that's basically it for question 7 Roman 1. Now let's go to question 7 Roman 2, which says find the inverse of the matrix A, where A is equal to this, hence solve the equations this. So you have the matrix A is equal to so that's 1 2 1, that's the matrix 1 2 1, negative 1 1 1, negative 1 1 1, and finally 1 negative 3 1 1 negative 3 1. Okay, now to find the inverse of this matrix, you have to find the cofactor of the matrix, and you have to find the adjugate of the matrix. The adjugate of the matrix is simply equal to the transpose of the cofactor. So adjugate A is simply equal to the cofactor of A transpose, that's cofactor of AT. And to find the cofactor of a 3 by 3 matrix is a very straightforward process. Let's input the matrix here, and right. So the transpose of a 3 by 3 matrix, simply need to understand that, like, we're going to block out an entry of the matrix as the horizontal and vertical, the digits which are horizontal and vertically related to it, and considering that this first entry of the matrix has the sign positive, this second entry has the sign negative, this third entry has the sign positive, coming out to the second line, this will be negative, positive, negative, and the signs keep alternating, so here it's going to be positive, negative, positive. So basically I'm going to explain what I'm trying to say. Take for example the first case, 1 is the sign here is positive, so that's going to be, we're going to block out this 1 2 and 1, and block out this 1 negative 1 and 1, and find the determinant of this 2 by 2 matrix, which is 1 negative 3 1 and 1. To find the determinant of this 2 by 2 matrix, we're going to multiply 1 times 1 minus 1 times negative 3, 1 times 1 is 1, 1 times minus 1 times negative 3 is negative 3, so negative is positive, so that's 1 plus 3. We're going to come to the second entry, which has the sign negative, so that's going to be negative into we're going to block out this, all these vertically related and horizontally related digits 1, all these vertically related and horizontally related entries to negative 1, and find the determinant of this 2 by 2 matrix, which is 2 negative 3 1 and 1. 2 times 1 is 2, plus 2 times 1 is 2 minus Negative 3 times 1 is negative 3, minus minus is positive, so that's plus 3. Then we do the same thing for this last part. It's a positive sign. 2 times 1 is 2, minus 1 times 1 is 1, so 2 times 1 2, minus 1 2, minus 1. We now come down to the second entry, that's 2. This is a negative, positive, negative. The signs are alternating. Here was positive, here is negative, so it keeps alternating. So 2 is negative, and the determinant here is, so we're going to block out 1 2 1 and 2 1 negative 3, and now finding the determinant of negative 1 1 and 1 1. Negative 1 times 1 is negative 1, minus negative 1 times minus 1 times 1 is negative 1, so that's going to be negative into negative 1 minus 1. Right. Then we're going to come to this second. The sign here is positive, so we're going to block out negative 1 1 and 1 and 2 1 and negative 3, and find the determinant of the 2 by 2 matrix 1 1 1 and 1. So 1 times 1 is 1, minus 1 times 1 is 1. That's going to equal 0. Now we'll come here and block out this 3, this negative positive. The sign here is negative, and find the determinant of this matrix 1 1 1 negative 1 1 and 1. So 1 times 1 is 1, 1 minus 1 times negative 1 is negative 1, so that's 1 plus 1. I'm going to come here and negative positive negative, so that's negative into this. Okay. Now finally, the last row, the sign is positive, negative, positive. So we're going to cross like this, and we're going to do negative 1 times negative 3 is equal to 3, minus 1 times 1 is equal to 1, so that's 3 minus 1, 3 minus 1. And then going to the part 1, you block this out, and find the determinant. 1 minus 3 is equal to negative 3. 2 minus 2 times 1 is equal to negative 2, so that's negative into, the sign is negative, so negative 3 minus 2. Finally, we're dealing with this one, which is, we're dealing with this one which sign is positive, so we're going to cancel this out and find the determinant of 1 negative 1 2 and 1. So 1 times 1 is 1, minus 2 times 1, 2 times negative 1 is negative 2, so that's 1 plus 2, 1 plus 2. And this is going to be equal to the 3 by 3 matrix. Okay. So 1 plus 1 is 4. 3 plus 3 is 5, so that's going to give us negative 5. Negative 5. 2 minus 1 is 1. Negative 1 minus 1, that's negative 2. Negative into negative 2 is 2. 0 is 0. 1 plus 1 is 2 times negative 2. 3 minus 1 is 2. Negative 3 minus 2 is negative 5 times 5 is 5. And finally 1 plus 2 is 3. So this is the cofactor of f of, this is a cofactor of the matrix A. And from here we need to find the adjugate of the matrix A. That's find the cofactor of the transpose of the matrix A. So this is the cofactor of A. Cofactor of A. Now the adjugate of A is equal to the transpose of the cofactor. So the transpose of this, so A transpose is simply equal to let's copy this, Ctrl C, Ctrl V. So here is negative 5 is going to be replaced by 2. 2 is going to replace 2. That's just simply taking this whole and I'm going to put it. Is it even a row? I'm taking this column and I'm going to put it as a row. That's transforming columns to rows and rows to columns. So 4 2 2 becomes 4 2 2. Negative 5 0 5 becomes negative 5 0 5. And finally 1 negative 2 3 becomes 1 negative 2 3. So that's 1 negative 2 3. So this is the transpose of the cofactor of A. Now we can proceed to finding the inverse of A. And this is the transpose of the cofactor of A, which is the adjugate of A. Now we can proceed to finding the inverse of A. To find the inverse of A, we need to find the determinant of A. This is A here to find the determinant. So now we have to find the determinant of the matrix A. That's determinant of A is going to be equal to, by using this, and as I said earlier, for the positive, negative and positive signs, we're going to start with this entry, which is going to be 1 minus minus 3. 1 minus minus 3 is going to be 4. And the second entry is negative times 1 is going to be positive 1 into 2 minus minus 3, which is 5. That's 4 plus 5. And the final entry is 1, which is going to be 2 times 1 is 2 minus 1 is 1. And if you add the determinant of A is equal to 10. Alright, so from here we proceed to find the inverse of A. The inverse of A, let's call that A inverse is simply equal to the 1 over the determinant of A, 1 on the A times the adjugate of A. So that's simply going to be equal to, this is the determinant of the adjugate of A, so go Ctrl C, Ctrl V. Then here is the determinant, so 1 on 10. 1 on 10 times this is going to give us A inverse. A inverse. And this is going to be equal to the question says find the inverse of the matrix A and hence solve the equation x plus y is equal to this. Alright, so this is going to be equal to fractions, and fractions. Control C, Control V. 4 times 1 on 10 is equal to 2 on 5. 2 on 5. Put the fraction 2 on 5. 2 times 1 on 10 is equal to 1 on 5. 2 times 1 on 10 is equal to 1 on 5. Negative 5 times 1 on 10 is equal to negative 1 on 2. Here is 0. 5 times 1 on 10 is equal to 1 on 2. Here is equal to 1 on 10. Here is equal to minus 1 on 5. And here is equal to 3 on 10. So this is A inverse. Now you see the next part of the equation says hence solve the equation x minus y plus z is equal to 7, 2 minus 2x plus y minus 3z equals negative 6, x plus y plus z equals negative 4. We're going to solve that using the matrix method, since this equation is basically this matrix form. So you understand that from this question, understand that multiplying these values, that's 7, negative 6 and 4, by this matrix, that's by the inverse of this matrix, are going to get the values of x, y and z. So we're going to do it like this. We're going to input a matrix which is going to be, let's put a bracket, and the matrix is, so the values are 7, negative 6 and 4, so 7, negative 6 and 4. Into this matrix we can use, into this, that's inverse of A, which will be is equal to x, y, and z. That should be this. X, y, and finally z. Oh no, actually it's supposed to be like this rather. Yeah. The inverse of the matrix times the value should be first x, y, and z. So now we can go to multiplying the values, or to make things easier, you can just use these values here. Like you can just use it like this and just multiply the 10 at the end. So I'm going to do this multiplied by this to get the values of x, y, and z. So x is equal to 4 times 7 is going to give us 28, plus 4 times negative 6 is going to give us negative 12, plus 2 times 4 is going to give us 8, and this is going to give us 28. Negative 12 plus 9 is going to give us negative 3, plus 28 is going to give us 25. Is equal to 25, and of course let's not omit times 1 on 10, so that's going to give us 25 on 10, or 2.5. This is equal to 5 on 2. So this is the value of x. X is equal to 5 on 2. Now we do same for the value of y. Y is equal to negative 5 times 7 is negative 35. 0 times 6 is 0 plus 0. And 5 times 4 is 20. And this is equal to y. This implies that y is equal to negative 35 plus 20 is equal to negative 15. Negative 15. And of course times 1 on 10, that's negative 15 on 10, which is equal to negative 3 on 2. And finally the value of z is equal to 1 times 7 is 7, negative 2 times negative 6 is 12, 7 plus 12, and 3 times 4 is 12. So 12 plus 12, 24, plus 7 is going to give 31. 31 times 10 times 1 on 10, that's 31 on 10. That's the value of z. Here are values of x, y, and z, implying that z is equal to this. So you have our values of x, y, and z, and you are able to have solved the equation with 3 unknowns using the matrix method. Now we are on question 8. Question 8 I said evaluate the sum to infinity from evaluate the sum from r is equal to 1 to r is equal to infinity of 3 into 1 on 4r. Okay, so that's a series, a geometric series, and we have to find the a. That's the first term. Let's call it t1, or let's call it a. No, let's call it t1. T1 is equal to T1 is when r is equal to 1, right? R starts from 1 to infinity. So when r is equal to 1, 3 times 1 on 4 is equal to 3 on 4. That's 3 on 4. That's T1. Then T2, or T2 is equal to, that's when r is equal to 2, that's 3 to 1 on 16. 3 times 1 on 16, which is equal to 3 on 16. And finally T3, let's end at T3, is equal to when r is equal to 3, 4 is the power 3, that's 16 times 4, 64. Yeah, so that's 3 on 64. 3 on 64. So now I need to find the common ratio here. The common ratio is simply T2 divided by T3 should equal to T3 divided by T2. So T2 divided by T3 is equal to 3 on 16 times, let's do this in normal fraction until it's clear. So equation fraction 3 on 16 times, let's continue see times 4 on 3 should be equal to control B 3 on 64 times 16 on 3, so that's 16 on 3. Now if you do the multiplication, 3 cancels 3, 4 cancels 16 4 times, so that's going to be equal to 1 on 4 should be equal to 3 cancels 3 here 1 time, 16 cancels 64 1 time, so that's going to be 1 on 4 as well. So you understand that it is a geometric series, it's a geometric progression with common ratio R equals 1 on 4. So GP with R equal to 1 on 4. 1 on 4. Now I want to find its sum to infinity. That's sum to infinity from R is equal to 1. The sum to infinity of a geometric progression A, or let's say T1, that's the first term, T1, or let's just call the first term A, all over 1 minus R. Alright, so this is equal to the first term, T1 is equal to 3 on 4. So that's okay. 3 on 4, 3 on 4, 1 minus R is 1 on 4, 1, R is 1 on 4, 1 minus 1 on 4. So 3 on 4, that's going to be 3 on 4, 1 minus 1 on 4 is 3 on 4, 3 on 4 divided by 3 on 4 is 1. So the sum to infinity is 1, right? So the sum to infinity, sum to infinity is equal to 1. That's the answer for the question 9, Romans 1. Wow. So that's the answer for the question 8 Romans 1. Now question 8 Romans 2 say the sum of the first n term of a series is given by Sn is equal to 2 into n squared plus n. Find the expression for the n term of the series. Alright. So the expression for the n term, we have the sum of the n term Sn is equal to 2n squared plus n. So 2n squared plus n. Oh. So that's 2n squared plus n. So this the tn term. The tn term here can either be the sum of the first n term. The tn term can either be can either be Sn minus S minus S n minus 1. So the sum of the nth term can either be the sum of the first n term minus the sum of the first n term minus 1, or it can be the sum of the n term, or it can be the sum of the n plus 1 term. That's the sum of the n plus 1 term minus the sum of the n term. So that's it. So yeah, this is n plus 1. So the Cn term can either be the sum of the first n term minus the sum of the first n term minus 1, or the sum of the first n term plus 1 minus the sum of the n term. Now we're going to use the first condition, Sn minus Sn minus 1. So Sn is simply 2n squared plus n, Control C, Control V, and Sn minus 1 is simply, we're going to substitute n minus 1 where you see n, so that's going to be 2 into n minus 1 squared plus n minus 1, and this is going to give us n minus 1 squared, that's going to give us this, Control C, Control V. N minus 1 squared is n squared minus 2n plus 1, so that's 2 into n squared minus 2n plus 1 into n minus 1. Alright. Oh, this negative sign goes here, so that's going to be n minus 1 n. Oh, let's just hold on for now. So like this is all in brackets because the negative sign affects everything inside here. And so that's going to give this 2n squared minus 4n plus 1. So let's open the brackets. That's going to give Control C, Control V, n squared minus 2n squared plus 4n. That's because the negative sign multiplies everything here, plus 4n minus 1 times, so that's minus 2, right? Minus n plus 1. And when you add everything together, 2n cancels 2n, n cancels, negative n cancels n, or 4n minus 2 plus 1, so that's going to give us 4n minus 1. So the n term is simply 4n minus 1. So the Tn term, the nth term is equal to this. So the next question says, show that the series is an arithmetic progression. To show that the series is an arithmetic progression, S, that's, say we're going to find the T1 term, the T2 term, and the T3 term. So let's just go with the T1 term. T1 term is equal to, we're going to substitute 1 where there's n, so 4 times 1 is 4, minus 1 is equal to 3, comma, the T2 term is equal to 4 times 2 is 8, minus 1 is 7, and finally the T3 term, so T3 term is equal to 4 times 3 is 12, minus 1 is 11. Then finally, to show that it's an arithmetic progression, T3 minus T2 is equal to T2 minus T1. So T3 minus T2 is equal to 11. That's Control C, Control V minus Control C, Control V. T3 minus T2 is equal to 11 minus 4. 11 minus 7 is 4. Then now T2 minus T1, that's T2 minus T1 is equal to 7 minus 3 is 4. So hence it's an arithmetic progression. So that's basically it for the question 8, A and B. Now moving to question 9. Alright, now we are on question 9, and question 9 says, prove by mathematical induction that for n element of natural numbers, the summation of 1 on 4r squared minus 1 from r is equal to 1 up to n is equal to n plus n on 2n plus 1. Alright, so proving by mathematical induction, you simply have to start by proving that for n is equal to 1, the left hand side of the equation is always equal to the right hand side of the equation. Then I assume the hypothesis, the left hand side of the equation is equal to the right hand side of the equation for n equals to a constant k. Then finally move to the induction step where you have to prove that for n equals to k plus 1, this value holds true, hence the equation 1 on 4r squared minus 1 is equal to n on 2n plus 1 for n equals to natural numbers. Basically what I'm trying to say is here are the equations 1 on 4r squared minus 1, that is so the equation 1 on 4r squared 1 on 4r squared minus 1 is equal to so here is the equation 1 on 4r squared minus 1 is equal to 2n, that is equal to n on 2n minus 2n plus 1, I think. Let's see. Yeah, 2n plus 1. So now we start by proving that for n is equal to 1, n equal to 1, we're going to substitute 1 in the place of r and in the place of n, and ensure that the left hand side is equal to the right hand side. So substituting 1 here, you get 1 all over 4 times 1 is 4 minus 1 is 3, so you get 1 on 3. Then this has to be equal to substituting 1 here, you get 1 on 2 times 1 is 2 plus 1 is 3, so 1 on 3, 1 on 3. The left hand side is equal to the right hand side, hence it's true for n equal to 1. Then assuming the hypothesis, let n, now verifying for n is equal to k. Verifying for n is equal to k. Verifying for n is equal to k. I'm going to substitute k in this left hand side and this right hand. We're going to substitute k in the left hand side and just going to write the hypothesis that k is true. That's n is equal to k on 2k plus 1. So after writing this, you can write the hypothesis that this is true for n equal to k. So after writing this, you can write the hypothesis that this is true for n is equal to k. Then our next step is to verify for n is equal to k plus 1. Now to verify for n is equal to k plus 1, we're going to substitute k plus 1 in this right hand function. In this left hand function, and add it to the k of this right hand function, and we have to manipulate it in a way that at the end we get a function which is the right hand function if we directly substitute k plus 1 into it. What you mean by that is verifying for n equal to k plus 1. Right. Now I'm going to substitute k plus 1 here, and you can notice this as the difference of 2 squared. So this can be written as, very well be written as 2r minus 1 into 2r plus 1. Then this should be equal to this plus, right, so this can be written as this. Now if substituting n k plus 1 into this function, we're going to get copy this. This is going to be equals to 2 into k plus 1, that's 2k plus 2 minus 1, that's 2k plus 1, so 2k plus 1, and here is 2k plus 2 plus 1, that's 2k plus 3 plus 3, and this we're going to add it to this what is substituted in here, so we're going to add it to this, and you have to show that this can give this function if it directly substituted k plus 1 into it. So when you add this, we're going to get that is going to be 1 plus this is going to cancel, and 2k plus 3 times k, 2k plus 3 into k, and all this will be over this, so you can just copy this, just paste it here and replace this one with this. So when you add this, this is what you're going to have. So now from here, what you're going to do is want to make this to this, want to manipulate this, let it end up like if you substitute k plus 1 into this. If you directly substitute k plus 1 into this, you are going to get k plus 1 all over. Hold on. If you directly substitute k plus 1, then we are going to get that's k plus 1 all over 2k is going to be 2k plus 2 plus 3, that's going to be 2k plus 3. So this is what we would have had if we directly substituted here. So I'm going to show that this can result to this. So looking at this question, we can easily factor out 2k plus 1 from the numerator, and that's going to give us 2k plus 1 into k plus 1. So that's 2k, hold on, that's going to result in 2k plus 1 times k plus 1, all that over this, no, all that over this. So now from here we can see that 2k plus 1 can cancel 2k plus 1, and this will be equal to k plus 1 over 2k plus 3. And you can verify this. Notice that if you open a bracket here, you're going to have 2k squared plus 3k plus 1. And if you open a bracket here, you're going to have 2k squared plus 2k plus k, that's 2k squared plus 3k plus 1. It's exactly the same thing here. We're just able to factor out 2k plus 1. And now 2k plus 1 cancels 2k plus 1, and we have k plus 1 all over 2k plus 1, which is exactly what we would have had if we directly substituted k plus 1 into this equation. So from there we can conclude that since it is true for n equal to 1, n equal to k, and n equal to k plus 1, it will be true for all values of n which are elements which are elements of natural numbers. Hence, you have completed the proof by mathematical induction, and that's it for question 9a. That's it for question 9.1. For question 9.2, it says a relationship R is defined on Z, the set of integers, by A related to B such that A minus B is even. Show that R is transitive. Okay, for a transitive relation, so say for example A is equal to B and B is equal to C, then A should be equal to C. This is a condition for the transitive relation. If A is equal to B and B is equal to C, then A should be equal to C. Now the relationship says A is related to B on the set of that integers such that A minus B is even. Alright, let's take for example A related to B, right, is equal to A minus B, and this should be even, so this is equal to 2, let me say any constant m, right? 2 times any number will result in an even number. Then A related to C, B related to C, say B related to C should be equal to b minus c, which should be equal to, let's say, 2 another integer n. Now for find the relationship of a related to b, we can add these two. So we can say a related to c is equal to a related to b plus b related to c, which is equal to a minus b plus b minus c, a minus b plus b minus c. That's, we're adding this a minus b plus b minus c, and this is going to give us a minus c, which is equal to 2m minus 2n, and that is, so we're adding this, so that's going to give us 2m plus 2n, so 2m plus 2n, and 2m plus 2n, you can write it as 2 into m plus n, so a minus c is equal to, that's small a minus c is equal to 2 into m plus n. Now you can just say this m plus n is obviously, this m plus n is an even number, as you can assume that since a minus c is equal to 2m plus n, which is an even number, you can say a is related to c, and if a is related to c, then the relation r is transitive, so hence the relation r is transitive. Now question 10 says find the range of values of x for which 2x minus 1 is less than negative 1. 2x minus 1 over x plus 2 is less than negative 1. Alright, that's question 10 Roman 1a. So the equation, the function 2x plus 1, that's 2x minus 1 over 2x plus 1, 2x minus 1 over 2x plus 2 plus 1, 2x plus 1 over x plus 2 out of the line, x plus 2 is less than negative 1, less than negative 1. Alright, so you have to understand that this denominator is not obvious, that is, the denominator is neither positive or negative. In case x is less than negative 2, then the denominator becomes negative. In case x is greater than 0, the denominator is positive. That's, in case the denominator is greater than negative 2, then the denominator is positive. So we cannot cross multiply to get like the range of values. Instead, what you are going to do is you are going to send one this way and I'm going to solve normally. So sending one this way, we get this control b and plus 1, and adding this, you get this is going to be equal to 2x plus 1 plus, that's 2x plus 1 plus x plus 2, x plus 2 all over 2x all over x plus 2. Yeah, so 2x plus x is equal to 3x. Oh yeah, this is equal to 3x, and negative 1 plus 2 is equal to 1. 3x plus 1 all over x minus 2. This should be less than 0. And now from here we find that the, like I can call that the zeros in this equation are 3x plus 1, let's say 3x. The zeros in this equation now can equate the numerator and the denominator to 0, so 3x plus 1 is equal to 0, and 2x, x plus 2 is equal to 0. The zeros are x is equal to negative 1/3, and here x is equal to negative 2. Now we can do this on the number line to get the range of values of which this is always less than 0. So now we can draw a number line to get the range of values for which this is always less than 0. So let's assume this is a number line. And see. Let's assume this is a number line, and say at this point you get negative 2, x is negative 2, and at this point you get x is negative 1/3, negative 1/3. So x is negative 2, x is negative 1/3, and from this point to x is negative 1/3, from this point to negative 2 are all negative, negative, negative. From this negative 2 to 3, that's the signs alternate. From negative 2 to 3, the signs are positive. And from negative 1/3 above, the signs are negative. And from here, we are looking for values which are always less than 0. That's the negative values. We're looking for values which are always less than 0, which always make this equation less than 0. Take a value less than negative 2, say negative 3, and you substitute in this equation. That's negative 9 plus 1, negative 8, and negative 3 plus 2, that's negative 1. That gives you positive value. So this is always greater than 0. So this is not the equation. This is always greater than 0. If you substitute any value below negative 3, it will always be greater than 0. Now if you substitute any value above negative 3, say 1, negative 1/3, say we take the value 1, you substitute 1 here, it becomes 3, 3 plus 4 is 4. 3 plus 1 is 4, and 1 plus 2 is 3, that's 4 and 3, which is positive. So this value is also always greater than 0. And now any value between negative 2 and negative 1/3, you can say we take negative 1. Negative 1 there is negative 3 plus 1, negative 2. Negative 1 plus 2 is 1. So negative 2 on 1 is equal to negative 2, which is less than 0. So this is the correct range. So now the range of f of x, the range of x for which this function is always less than 0 is negative 2 less than x less than negative 1/3. So this is the range of values for which the function is always negative. This is the range of values for which the function is always less than 0. And that's it. Question 10.2 says the absolute value of 2x minus 4 less than x plus 1. So the rule of an absolute value sign say the absolute value of a, which is less than x, is simply equal to make a be in between negative x and positive x. So a between x and positive a, that's x is between negative a and positive a. Now applying that to this, we are going to have, this is our inequality, and putting it here, we have, this is our x, so this is simply going to be equals to negative x minus 1 is between 2x plus 4, which is less than x plus 1. Now we can take the first case, x minus 1, and solve it to get minus x minus 1 is less than 2x minus 4. And solving this, you get, if you send x this way, it's going to get positive 3x, and send 4 this way, it's going to get minus 3. You're going to get plus 3, so sending negative x this way becomes positive x, that becomes positive 3x, and sending negative 4 this way becomes positive 4 minus 1 becomes 3. So 3 is less than 3x. So 1 is less than x, or x greater than 1. That's our first value. Now going down to the second case, 2x minus 4 is greater than 2x minus 4 is less than x plus 1. So 2x minus 4 is less than x plus 1. If you send negative x, if you send x, it becomes negative x, that gives, if you send x this way, it becomes negative x, that gives us x. And if you send negative 4 this way, it becomes 4, that gives us x is less than 5. So now if you join these two inequalities, it's going to give us 1 is less than x, which is less than 5. And this is the answer to the question. Now question 10 Roman 2 says the complex number z1 and z2 are such that z1 is equal to negative 2 plus 2i and z2 is equal to negative 2 minus 2i. Find arc z. Okay, the arcgan of z1 is equal to tan inverse, that's tan inverse that's 2 all over 2. We're not going to, this negative sign does not affect the angle we're going to get now, so that's going to be equal to tan inverse 2 on 2 is 1. Tan inverse 1 is equal to 45 degrees, or pi on 4. So now this where this negative sign comes in place is to understand the quadrant in which this complex number is found, in which this point is found. And understand the quadrant, you see that the x component is negative and the y component is positive, and that happens in the second quadrant. To explain what I mean, understand what I mean. Come on, bro. Right. To understand what I mean, when you draw a graph, let's say this is the y-axis and this is the x-axis. This is the first quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And here you see the values of x are positive, that's the value of the x-axis are positive, the values of the x-axis are negative, the values of the y-axis are positive, and the values of the x-axis of the y-axis below are negative. So the quadrant in which the values, so the quadrant in which the y-axis is positive and the x-axis is negative is the second quadrant. And the second quadrant, the angle is equal to 180 degrees pi minus what you got. So what you got here was so the angle you get from the second quadrant is 180 degrees minus the angle you're able to calculate, say, minus angle you're able to calculate. So from our calculations, we got that the arc of z1 is equal to 45 degrees. So since z1 is located in the third quadrant, in the second quadrant, we're going to take 180 minus 45, which is going to give us 135. And if we're going to write this in terms of pi, it's going to give us 3 on 4 pi. Let me see. Alright, so this is going to give us that's 3 pi on 4. So this is the answer in terms of pi. And now the second question says that's the modulus of z1. Actually there was an error. The actual question was the modulus of z2 raised to the power 6. So that was something like this, of z2 raised to the power 6. So this was the second question. And that's this is equal to the square root of, what is square root? Square root. The square root of 2 squared plus 2 squared, that's the square root of negative 2 squared plus negative 2 squared, that's the square root of 8, which is equal to 2 root 2. 8 raised to the power 6. So this is going to be raised to the power 6. That's the entirety of this is going to be raised to the power 6. Okay, raised to the power 6. And this is going to give us 2 raised to the power 6. So 2, and this is equal to 8 is equal to 2 root 2, right? 2 root 2 raised to the power 6. So that's 2 raised to the power 6 we have. So 2 raised to the power 6 is 64. Raised to the power 6 is equals to 8. So 64 times 8, let me see, is equal to 512. So this is the answer of the last question in Cameroon GCE Advance Level Mathematics Mechanics Paper 2 of the year 2020. Alright, you have come to the end of this video. If you followed us up till this point in time and learned anything new, then please do consider leaving a like or a sub if you're new. Thank you all for watching, and we'll see you to the next one. As usual, these documents are going to be uploaded on the GC4 website for free download, so do not hesitate to go and check. And thank you all for watching again. See you all in the next video.